Okay, it's recording now. Okay, cool. So, what I want to do now is not talk about our opinions of sushi. That is an approved pre-class CS topic. Instead, what I'd like to do is I want to work through an example of how to take a regular expression, turn it into an NFA, turn that NFA into a DFA, and then minimize that DFA. I want to walk through the whole thing. And so let's turn the lights on so that way we have better lighting for our camera. Ooh, fancy. So let's start off with I'm going to start off with a regular expression that's going to be somewhat annoying, intentionally so, because this is exactly how it will go if you are interviewed. Is you will get something that will have a particular set of annoyances in it. And the best way to be annoying when you're making a regular expression is to include ors within that keen star. It's gonna suck. I'm not gonna make it suck too much because I would like to finish it during class time. So let's put in here. We have. You can do AA or AB or AC star. And now I'm adding extra parentheses here just for clarity. I want just to hit home. The order of operations here is obviously parentheses occur first, concatenations second, ors third, keen stars fourth. So if I were to be explicit about all parenthesization on here, it's like this. So it's not A concatenated with A or A. Now, I mean, that'd be silly to have A concatenated with A or A. It's a valid regular expression. So that makes sense?
It's one of those pairs, then keen star.
So it is one of these pairs, keen star. Now, keep in mind with the regular expression, we're going to have more than this. I'm going to add a little bit more, but if we were talking about just this, you could have AA or AA, AB, AC, and you can keep on oscillating between any of those three. Okay?
I mean, that would just be three separate epsilon paths, wouldn't it?
It'd be three loops through this because of the keen star.
I mean, just that you'd have three separate. It would be we're branching with three paths, and there'd be.
Well, we'll get to the whole NFA process in just a minute. We're not there yet. Because we have to actually finish.
Just doesn't seem that hard in and of itself.
No, we'll get there. And then A followed by B star. I clearly hate you by doing this. This is clearly a sign of hating y'all.
So would it be A parentheses B star?
Mm-hmm.
Okay.
Oh, so A, then E.
Then A, then any B star.
So just B's.
As many B's as you
B's
want.
Yeah. What?
B's only one repeated.
Yeah. So let's be clear about order of operations because I might have misspoke earlier. 1, parentheses. 2, keen star.
Yeah, keen star.
Yeah, I had a mistake on keen star. 3, concatenation, which is also another great name for an art show. Actually, I think it's better for a band. Concatenation.
Concatenation? Is that how you spell it?
No,
Oh.
but that's how I would spell it if I was going to make a rock band with it. What? Yeah.
It doesn't bring out enough.
Is it E in there?
Concatenation. And finally, 4 is the or. Everyone cool with this?
So with this regular expression,
Mhm.
empty set can't exist because of that A at the end, right?
Wait, what?
The empty set can't exist.
Right, because of that A.
Okay.
Right. So it has to have at least one A in it. So now, the first thing we want to do, so we have a regular expression. I'm going to erase this so I have room for everything. You got a camera? Okay. So, step one, turn this into an NFA. Now, as AJ noted, we have a series of ORs here. If we were to be explicit about this, and we were to do it using that notion that I talked about earlier, we would want to do it 2 ORs, maybe those 2 first, and then that's an OR with that one. Does that make sense? It's just like with addition, when you say 2 plus 3 plus 4, are you adding 2, 3, 4 at the same time? No, you're adding 2 plus 3, and then adding that to 4, and then saying, oh, that's 5, adding that to 4. No, we could do that for the same thing here, but when you have a series of ORs like this, it's very easy to see how you extend that. So I'm going to take a shortcut here and not view it as a 2 and then a 3, because that will actually make it very long. Instead, rather, what I'll do is I'll say that we have our start state, and then I can go to an epsilon for A, like so, and then another epsilon Does that make sense? And so if I'm talking about showing steps, this is probably if we're talking about showing steps forward, this would be the first step I'd want you to show. I wouldn't expect you to show the step for creating the A Turing machine. I think y'all can handle that. So I'll go ahead and I'll join those 2 together and make one Turing machine, one DFA for the combination of those 2. Yeah. So the second step of this is to make one that starts off accepting A, and then epsilon, B, epsilon, accept, epsilon, epsilon. Everyone cool with this? Alright, now during a job interview, the next thing you probably would do would be like, well, maybe I should move that over there. Again, when you're doing this on the test, you want to spell out every step, so if you make a step mistake along the way, I can find it easily and give you partial credit. And just as a heads up, about 80% of you will make a small mistake along the way. And that's fine, it was not fine. It's not that bad. It'll be a point off if you are showing your work. Because it's very easy to be like, oh, whatever, and then you forget that epsilon there. And you forget that, and then all of a sudden your thing gives you nonsense at the end. It accepts a string that it shouldn't, or it doesn't accept a string that it should. If I see that, oh, you just forgot it there, I'll take off 1 point. If you showed no work, and then you have a horked thing at the very end, then I get angry. That's not true. I get mildly annoyed. All right. Then now we need to join them together.
You forget the star number.
Which one? Oh, I haven't done that part yet. I've just done the ORs.
That'll come in.
That'll come in. Now I want to turn this whole thing into the star, and then I want to join them together. So I'm not going to rewrite this out because it's going to take a lot of time and we're lecturing here. But what you want to do now is we need to add the star to it. So we add a new start state before, and we put an epsilon transition there. And then we put a new nth accept state there, epsilon transition there. we have an epsilon transition connecting those back, and then an epsilon transition connecting those. Everyone good with this? Okay. The next thing we need to do is join them together. This is the easiest step of them all. All we do is you delete that node, you delete that node, and just say, whoop, yeah, stretch it out. And this is the NFA which accepts this.
Wouldn't that require a third A before it reaches the accept?
There's one right here.
Oh, okay.
Alright, now let's number them, because now we have to turn it into a DFA. Told you I hate you guys. I'm doing this on the board. Guess what level of complexity of question I'm going to ask you on the test? One that I did on the board, or one that I didn't do on the board? 0, 1, 2, 3, 4. Now I can number these in any way, but it's going to make my life a little easier if I do it this way, just because it's always going to sort of think ahead about how should I be numbering these to make my life easier. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
Okay, I'm so confused. Isn't it supposed to accept AA?
What?
Isn't it supposed to accept?
Nope.
What?
It
Nope.
has to have
It would
A.
be AA.
It accepts 3 A's.
Triple A.
Yep. We're gonna need more board space. Yeah, now I have to move the.
She still had to erase once.
There we go.
Took 5 days in the exercise.
Did they put up a third board? Oh, they did, didn't they?
Oh, yeah, that was.
Yeah, they shifted all the boards over. It's new, you can tell because there's a different.
I heard like walking in on Wednesday and be like, "It's just something wrong with this
Yeah,
room."
that's alright, yeah.
I didn't know this must have happened when I was out, or
It happened a couple days ago.
Oh.
I know it was in there yesterday.
I had no note. Yeah, I did not realize it. Okay. So, anyways,
17.
Okay.
Let's just make the walls whiteboard.
we really should have just painted all the walls with whiteboard paint. So let's now. So now we want to turn this into a DFA. So how do we do that? Well, the first thing is we start off at our start state. Every state that's an epsilon transition. That's the edge of my camera. Okay, good. So that's where I can write to. So.
That's me.
So what we're going to do is we're going to make the start state, and that's going to be the state that you originate in, and everywhere you get from an epsilon transition.
And X.
So 0, 1, 2, 3, 4, 12. 0, 1, 3, 4, 12.
2.
1. How did I miss that? 2, 3, 4, 12. Okay? So now we say everywhere you can get to from there on A, B, and C. Well, B and C are easy because you can't get anywhere from there on B or C. Because 2, 3, 4, 12 only go places on A. And the other ones just go places on epsilon, so they don't even matter.
On the test, will you want us to draw this self-loop
What?
failures? So like on B and C?
No. No, and you can just omit those, and that's just common practice to omit them. I may ask you to do it on one problem, draw, and I will state specifically, draw failure states, if I want you to.
So the next note is everywhere that those nodes go from A, B, and C.
Right.
But it's only
It's really, in this case, it's only A. Because the only, so 0 goes nowhere on any letter, 1 goes nowhere on any letter.
So this is
2, 3, 4, and 12.
And
Go places
anywhere
on
you
that.
attach with the epsilon, right? And
What?
And then it just follows through.
And it follows through on epsilons as well.
so we also do
13 and 16
So this will be,
and 14.
this will be an entity.
This will be an instant, yeah.
Wait, so the second part, what's the second
Okay.
part?
anywhere you attach with an epsilon transition,
Yeah.
and you always follow through to the end of it.
So here, let's go through this. So on A, 2, 3, and 4, we'll go to 5, 6, 7.
Yeah.
Okay, so we have in here 5, 6, 7. 12 goes to 13. 13 can also go to 14 and 16 via epsilon transition. So we have 14 and 16.
Oh, so once you go through the letters, you then keep going through each epsilon.
Yeah. And now this is an accept state because 16 is in it.
Only process.
So now we have to do everywhere this goes on A, B, and C. Now we actually get different things going on here because we actually have a B and C. So let's do C first because that's actually the easiest one of these. C has the fewest number of things that we'll be doing. So where do you go on C? 10. You go 10, 11, 12, 1, 3, 2, 3, 4.
On.
Sweet.
Alright, let's do them in order. Okay. Let's do them in order from left to right. That'll be easier because when we have this duplicate state again, we might hit them in a different order. So it'll be a lot easier if we keep track of that. That sound good?
Yeah.
Okay. So we can go to 1, 2, 3, 4, 10,
10, 11,
11, 12. Is that it? Yeah. Okay.
Wait,
So-
zero.
What? No. No. You never get back to 0.
Just make it.
See, this is why the epsilon, we talked earlier about why not having the self loops on epsilon. Like, so why have these separate pullout states? Is it actually makes this process a lot easier. Because now you never get back to 0, so you never need to worry about that again. 'Cause once you leave it, you're gone. Okay, so now we're in 1, 2, 3, 4, 10, 11, 12. Let's do this one for A, B, and C. Where can you go on C from this state? I'm on this state now. 1, 2, 3, 4, 10, 11, 12.
At this stage, there's nowhere to go from C.
Right. How about B? How about A? What states do you go to? You can go to 5, 6, 7, 8, 9, 10. Oh, this is 5, 6, 7, 13, 14, 16. Hey, what convenience! 5, 6, 7, 13, 14, 16. It's the same. This is not a difficult process. It's more annoying than anything else. And it's very, very easy to make a mistake because if you accidentally forget one of these numbers, you can have an entire another state. Now, sometimes it actually doesn't mess you up if you can look at, and it's always good to look at this and be like, is this doing what I think it is? And thinking about this, okay, so you have AC. So we had AC. Now, once you have that, I should be back in the same state I was originally here. I should be back at this point. That makes sense. So if I see an A again, it'll put me back into that initial state. Everyone cool with that so far? Let me just make sure that this is, so we have an A. I feel like there's something wrong here.
Is there no B?
What? No, there can be no B, that's not a problem. Okay, no, this is ACA. Yeah, no, this is good. All right. Yeah, because to be, so if you were to follow this, to be A, C, A, is that string accepted by that? Yeah. So we're still good on the trolley. I just wanted to make sure I didn't forget a state. No, that's next year. I gave you a preview of that earlier. Okay, so we're done with this state. Now let's go back up to here. Let's do, where do you go on A from 5, 6, 7, 13, 14, 16?
8.
Hey, wait. All right, you're gonna go to 8, 11, 12, 1, 2, 3, 4. 1, 2, 3, 4, 8, 11, 12. Okay. This state, where do you go on B? Nowhere. Where do you go on C? Where do you go on A?
Back to
I'm hoping back to one.
5, 6, 7. I think one was.
I would say that.
So here, just give an idea of, like, let's get an intuitive idea of what's going on in here. So we have this initial state where we're leaving the initial state with an A. So this A right here, that A we see over here could be in several different places. That A could be the first, that A, or it could be that, or that. We don't know. If it's the next letter we see is an A or a C, then we know that that first A referred to an A there or an A there, which meant that's a keen star, so it takes us back to that initial state. So now we still, so once we have that, we know we're in here, we're in the A, we are in that A or that C. Well, what do we need to be an accepting state? An A, which is why that A and that A take us back there. Or that A resets us back to the possibility of being A. So, it's cool, isn't it? Always good to keep up with that reasoning, so when you're going through this, because again, how easy is it to make a mistake in here? Super, super easy. That reasoning will help, keeping track of that will help so you don't make any mistakes. Okay, now unfortunately we have to do B. I've been trying to avoid that one, and B is not the same boat. Okay. I like how every step there's a sigh of like someone who's about to run a marathon. It's like, okay, let's do this. Okay, so on B, where do we go? So 6 will take us to 9, 11, 12, 1, 2, 3, 4.
How does it go up to the stars?
It doesn't. 11 does.
Oh, okay.
So let's do that part first, because also I've ordered them in a nice way. So we know that the first part of B, and this is not all of it, it's going to be 1, 2, 3, 4, 9, 11, 12. But that's not all. It can also be, if we were in 14 in our original state, B could take us to 15, back to 14, and 16.
So 1, 2, 3,
14, 15, 16. And that's an accept state because there's B. Okay. From this, let's do the easy one first. Where can I go on C? Now this is easy. Is 7 in that state? No. Is there a C anywhere else in here? No. All right, that's going nowhere on C. All right, where can I go on A?
Hopefully not second rule.
6, 5, 6, 7.
Yep, it's backwards. Again, intuitively reasoning about this. If we saw a B and now we see an A, where can we? What is that? What was that B? Where was that B? Was it there or was it there? Well, it must have been there. So an A means that we're back into that state that we'd already created.
Can we draw this like a function? Can we do if they're the same, like the top node, can we do the same line?
What do you mean? Oh, you mean like
Both A's?
no. Drama is 2 separate ones. That's a good question. Don't do it. It's very easy to make mistakes with that, and that's the reason why. Because if you accidentally draw one of your arrows less smaller than the other one, and then you're reading back through it later, it's very easy to be like, oh, guess it was only going one way. All right, where does this go on B?
14.
Yep, it only goes to 14, 15, and 16. Why does it only go to those 3 states?
There's no loop back to the main or to the
Right,
first.
and this means if we're here, it means we've seen 2 B's in a row. We've seen 1A, and then 2 B's in a row. We've seen some gobbledygook, which had at least 1A in it, and then 2 B's in a row. So we must be at the end state. Okay, 14, 15, 16. A and C, where to go?
Nowhere.
Nowhere. Where does it go in B?
Self loop.
Yep. Everyone good with that? All right, let's move on. No! No! The best lecture notes I've ever given. Yeah. All right, this marker ends. Okay. It's important to frame your shot. Watch, I'm recording this all backwards, and you're like, Aaron, damn it. Okay. Now, to make life easier, I'm going to put new numbers on these, because I don't want to have to write out the state, 5, 6, 7, 30, blah, 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 blah. So I'm going to renumber these for the sake of it. Having a second pen, a color pen, is going to be really handy for you. I'm not saying now, but but
Test day or something.
on the test day, just as a pro tip. Now, for some of you, having a first pen or pencil will also be here. But if you remember that first one, remember a second one. So, I'm going to call this state, damn it.
It's like state down.
Oh.
Guard block.
Yeah. 0. I don't want to call that 1. 1, 2, 3, 4, 5. I have an idea of how this is going to merge together. How do you think it's going to merge together? Guess which two states are going to join? Based off of Aaron's numbering.
1 and 2.
So let's go through, and we have to establish an initial partitioning of now. I know one thing I want to keep in mind when you're numbering these things. You know, accept states and non-accept states are never going to be together. So it's very helpful to number them so that all the accept states are sort of the end and non-accepts at the beginning, because you know straight up they're going to be two different partitions. So we come up with our initial partitioning. X1 is going to equal 0, 1, and 2. X2 is going to equal 3, 4, and 5. Let's see if this works. So I have X1. So I have, sorry, I don't know what I'm doing. 0, 1, 2, 3, 4, 5. And then I have A, B, and C. Okay, where does 0 go on A? Which is in partition X2. Where does B go? Oh, where's it go on B and C? Nowhere. Where's 1 go on A? X2. Where does it go on B and C?
No.
Where does 2 go on? Where does 2 go on A? Okay, where does 3 go on A?
X1.
It goes to X1. And where does it go on B?
Goes to X2.
And where does it go on C?
X1.
Where does 4 go?
It goes to X2.
And it goes to X2. Where does it go on B?
X2.
Where does it go on C?
Nowhere.
5. Where does it go on A?
Nowhere.
B?
X2.
C?
Nowhere.
Okay. So those 3 are still so good for our partitioning. I hope the camera didn't fall asleep. Oh well. It's the consequences of being unplugged. So that's where. So this partitioning is going to not entirely valid. We can now try another attempt, and we will keep 0, 1, and 2 in the same partition, but we will make a different partition for 3, 4, and 5. Notice that if you ever get to a point where every state is in its own partition, then you would have found the minimum. We're not at that point, because if every state's its own partition, then hey, this is the minimal thing, and you don't have to redraw it. That's an awesome question for me to ask. Where it ends up like that. If that's the case, then you have to you don't have to redraw it out, but you have to go through this process to show that it's the minimal. You can't just say this be the minimal partition yo.
It's hard.
Yo. You put yo on there, it's definitely going to lose you at least half a point, which will be rounded down. Normally I round up with just half point losses, not that one. Now, here's the lazy man's way of drawing this chart, which is that like so I can erase this up here and that's fine. Guess what you don't want to do on your test? Erase it. But you've already done write this out 0, 1, 2, 3, 4, 5. Why should I have to write that out again? I'm so lazy. I actually tend to write these in a row like this. Now this representing the next partitioning of it. And then above it, I'll write what my x1 and x2 are. x1 is equal to 0, 1, 2. My x2 is equal to 3. My x3 is equal to 4. My x4 is equal to 5.
That's gonna get a little confusing.
That's why I write them with x's. Okay, so on 0, on 0a, where do I go? x2. B? I fill in the nowheres, that doesn't change based on our partitioning. Okay, 1, where do I go on A?
X2.
x2. 2, where do I go? x2. And then I know these are all individuals, so I know they go to they only go to the one place. So I have to just look at that and basically say, okay, 3. So 3 on A goes to x1. On B it goes to x3, and then x1. 4 will on A will go to x2. On B it goes to x4 dash dash x4 dash. These partitions all go to the same spot. This partition goes to the same spot as everything else in itself, which is just itself. Same thing there, same thing there. So now we can draw out the minimal DFA for this. The minimal DFA for this, we'll just use this chart, and that is x1 is our start state. Again, note it's our start state because 0 is included in it. That's what makes it a start state. And then on A, it takes you to x2, which is an accept state. x2. Now, Deshaun, what you can do if you want to simplify it is you can put 2 letters on the same line. So B and C will take you back. Sorry, A and C will take you back. I should read the chart I just wrote. Really easy to make a mistake. So A and C take you back. x2 on B will take you to x3. On A, that will take you back to x2. And then on B, that will take you to x4. And x4 will loop forever on itself on B. Now keep in mind, we haven't shown the reject states here. So if you just glance at this, you look like, oh, well, it accepts all things that start with A, right? And there's a lot of places to fail there. I guess you can't really fail there, but you can fail there or there. If you were to put in, say, a C there, or an A or a C there, those would both cause you to fail. Or anything other than an A there. And then you can intuitively way through it. Does that regular expression have to start with an A? Yes. Then can that take you to an accept state if you just have a single A? Yeah. Now if you have an A or C, it sort of resets you back at the beginning. If you have a B, well, it could be a B at the end, or it could be a B that resets you back to the beginning. You don't know yet. But if you just see AB, that's perfectly valid. So that's an accept state. If you see an A after 1B, you're like, oh, that means I have to get reset back to that initial state, that initial looping state. In which case I'm still waiting for then. That could also be an accept because it could have been ABA, so that's still perfectly valid. But if I see another A or C, it's like, oh, nope, that was just still me being in the middle. But if I see a B after it, I take me back to there. And then if I ever see 2 B's in a row, then I'm in the self-looping state and I have to be there.
So what's going on in chart 3 and 4? One or X1, X3, and the X2 and X4 are viable destinations, but X4 would be self-looping, wouldn't or no
X4 is looping. And so what we have here is if I rewrite those numbers next to it, this partition is X1, then X2, X3, X4.
I mean, like wouldn't for 4 wouldn't or no for okay, yeah, it's confusing.
If you want to write them out, like this helps me. If you want to write them out as separate charts each time, you're more than willing to do that.
What makes the bottom 3 on this side minimal compared to that side?
This is so over here. That's 3 separate partitions. Here, this is 1 partition, just X2.
So those are 3 sets with
Yeah.
unique locations, or unique destinations.
But what makes that right side? Because we kept all of those.
So what makes it so what makes this not minimal? So this X1 here, X1 partition, that's good to go. The problem, that's good to go as far as this is concerned. What's bad down here is that X2 is behaving differently for each of the states.
So you have to separate.
You have to separate them out.
Okay. That's all.
And now what you have to do is after you separate them out, the separating them out could cause X1 to mess up.
Okay.
Which is why even though X1 looked good here, it happens that it maintains. But it could have been that separating them out caused those to split up now. So you have to redo the whole thing.
So it's just a matter of grouping all these nodes into their own sets of nodes such that
Right. And you start off with the smallest possible one, which is accept and reject. Or accept and not accept. Because you know those have to be different. And then you work from there and be like, okay, I know I have at least 2 different, at least I have no, if I have accept nodes and non-accept nodes, I know I have at least two different nodes in my system. So let's see if that works. Does it work? No. It doesn't work in this case because the accept nodes have to be separated. And then you come over here and you're like, okay, let's see if the whole thing works. It could have been separating the accept nodes caused the non-accept nodes to fracture. For example, and again, suppose that you had this line had not connected to this A, but had instead connected to there. If that had been the case, it would have looked like that node, they all would have been functioning the same initially, but then after that change occurred, now this node would have been pointing to, which one is that? X3. So you would have had to refracture that and then try a new partitioning to see if that works. Eventually, when you get to the point that every element in a partition behaves the same way on all inputs, then you know you've reached a stable partitioning, and that's valid. And that represents the minimal partitioning. For those playing along at home, I connected which node was it? The node 0 with node 4 via A temporarily via a super cool dash line. They didn't? No! Okay, we better do that quickly. There we go. What's funny is you can't hear any of y'all on this, so it'll just look like I've gone crazy. Which is actually what it looks like when I watch myself.
Should repost these as crazy professor.
I also didn't realize how much I laugh at my own jokes, and how big my teeth are when I smile.
rest of the lectures goes to class.
So it's not straight, just adjusted. Okay. Yeah, so that's it for today. Wanted to work through one giant example.
We're not gonna have homework.
Yeah, no, I'm gonna give you guys post a homework assignment online.
For the rest.
Uh-huh.
Gonna do the
For example of this will be in the test, and it will be of this size.
What?
Maybe that's just
Oh no, the one of the tests will absolutely be this difficult.
Okay, so it will be the test?
Nope.
Okay.
There'll be other things on there. No, the thing is that like it took a lot longer because we were explaining each step along the way. Like I would expect you could do this in a half hour.
What about homework?
I'll make the homework due next Friday.
Okay.
And guess what you're gonna have on the
Homework?
you're gonna have just like 4 or 5 of these.
Oh really? Cause this?
It's gonna be just doing
Okay.
these for like 4 or
Is
5.
NFA? No DFA?
Well, this is DFA.
Go Latrine.
I know the DFA, but I mean they start with the NFA because I cannot start with the DFA. I can only start with NFA.
Oh.
If we get one wrong, we just